Do you want to learn how to make an enemy possession script for Terraria? Well, if so, this advanced cheat engine tutorial is for you. Turn on your game, turn on cheat engine, and let's get right into it. The first thing you want to do, as always, is attach your process. Then go ahead and make a character if you haven't already, make a world and load into it. Now in this one we're going to need to get hit a lot. So to help us along, we're going to make a quick God mode cheat. Simply search for your health, get hit, search for the new value, and repeat until you find your health. You can verify you found the right one by changing the value and seeing if your health changes. Once you find your health, right-click it and find out what writes to this address. Then get hit one more time. You should see a sub instruction pop up. Go ahead and click on it, show disassembler, tools, auto assemble, template, and AOB injection. Basically, this is going to hook onto the part of the code that runs whenever we get hit by an enemy. Now our change is going to be very simple. All we're going to do is change this sub to an add. Now, whenever we get hit, instead of subtracting health, it's going to add health, making us functionally immortal. Next, we're also going to allocate a custom variable like so. We're going to call it player and give it 4 bytes. This function exposes the player's base address, which we're going to need for the script that we're going to write later. So go ahead and make the exact changes I do. If you want to learn more about how the player base address works, you can watch my video about it, but it's not too important for this tutorial. Also, if in your version of the game, a different register is being used instead of EDX, just replace it with that register. Now go ahead and add the script to your cheat table, hit add address manually, add that player base address, and attach it to your script. Then I'm going to change their descriptions just to make them nicer looking. Okay, perfect. Now you can enable your script by checking the box to the left. Now if all went well, once you get hit you won't take damage, and the player's base address's value will change from 0. Go ahead and double click this address and enable pointer. Then copy the address from up here because we're going to need it. We're going to be searching for the player's position, and having the player's base address is going to help us significantly. In your memory scan range, go ahead and change the start to this address and the stop to this address plus 2000 or so. This is basically going to restrict our search to values that are near our player base address. Change your value type to float and your scan type to unknown initial value. We're going to look for the player's X coordinate first, so every time you move to the right, search for an increased value, and every time you move to the left, search for a decreased value. Eventually, I was able to narrow it down to about 30 values or so. Now we want to narrow it down to the one that actually affects the player's position. So what I'm going to do is I'm going to add each and every one of them to the cheat table, and I'm going to change them one by one until the player moves. Now as you can see, the very first one I changed actually moved the player on the screen, so I know it's that one. But don't get discouraged if it takes you more than one try. Once you find it, you can go ahead and change the description and get rid of all the other ones. Once you've got the correct value, go ahead and right-click it and find out what writes to this address. When you move, a bunch of instructions should pop up. We don't actually need to do anything with these, but the important part is that plus 20 that you see in a lot of them. This is the offset from the player's base address where their X coordinate is being stored. I'm going to go ahead and copy-paste my player's base address. So just Ctrl-C, Ctrl-V, and I'm going to rename it to player X. Then I'm going to double-click the address and change this offset to 20. Make sure you change the type to float, and now it should correspond to your position. Now we're going to copy-paste this one, and we're going to look for the player's Y coordinate. The player's Y coordinate is actually likely to be near the player's X coordinate in memory, so what you can do is just increase and decrease this offset until you find the similar looking value. I found it at offset 24. Again, you can verify you found the right one by changing the value and your player should teleport. Okay, now that we have the player's position, one step of the puzzle is complete. The next thing we need to find is the enemy's position. We're going to follow pretty much the exact same process but with the enemy, so change your value type to 4 bytes and look for the enemy's health. Also make sure you reset your memory scan range by selecting all again. Now go ahead and search for the enemy's health, change it by giving it a light smack, and look for the new value until you narrow it down. Once again, go ahead and verify you found the right one by changing the value. Just like before, we're going to right click on this value and find out what writes to it. Go ahead and hit the enemy one more time, and again it's going to be a sub instruction. Show disassembler, tools, auto assemble, and AOB injection once again. Now this time we're going to get the enemy's base address, and as you can see the register that's being used is EBX. So go ahead and allocate an enemy variable 4 bytes again, and just move whatever is in EBX into the enemy variable. If you'd like, you can also again change the sub instruction to an add instruction, but this is going to make enemies immortal. So if you want to avoid killing them, go ahead and make this change, but if you don't have to. Assign it to your cheat table, okay, and close all this out. I'm going to go ahead and enable the script and change the description to something appropriate. Then I'm going to add address manually and add that enemy variable that we created. Now once you hit the enemy, you'll get the enemy's base address. Again, we're going to use this to get the enemy's position, so go ahead and copy paste this value. Then we're going to look for the offset that corresponds to the enemy's position. Now for the player, the offset was quite small, so we can assume that it will be for the enemy as well. Go ahead and change both of these to pointers, and then you can slowly just increase the offset until you find a right looking value. Don't forget to also change the type to float. Now it turns out the enemy's X and enemy's Y coordinates are actually stored at the exact same offsets that they are for the player. So it's going to be plus 20 for the enemy's X coordinate and plus 24 for the enemy's Y coordinate. You can then freeze both of these values to trap them in baby bitch jail for all eternity. But we have better things to do with them. We have our player's position, we have the enemy's position, the final piece of the puzzle is our cursor's position. Okay, this is going to be a warning from future me. Turns out this next segment of the video is profoundly stupid. There is a native get mouse position method in Lua that lets you get the mouse's coordinates. So if you'd like, you can skip to the coding segment of the video and just replace the way I get the mouse's coordinates with this method. Alright, so just like with the player's position and the enemy's position, we're going to search for an unknown initial value. We're going to do the cursor's X coordinate first, so when you move your cursor to the right, search for an increased value, and when you move your cursor to the left, search for a decreased value. This is rather difficult without being able to pause your game because your cursor will move as you go and try to scan in cheatengine. So I do recommend enabling the pause hotkey in cheatengine settings. Pretty soon you should be left with a dozen or so values. I'm going to go ahead and grab one of these green ones. The green signifies that it's a static pointer, which means that it's likely to persist across game resets. Which is perfect for us because we want to turn this into a cheat table that we can use over and over again. As you can see in the video, I turned it from float to 4 bytes. This is because, as you can see, the original value was an extremely small number, which means cheatengine is probably interpreting the bytes wrong, which means we probably have the wrong data type set for it. The next thing you want to do is find the Y coordinate as well. It's the exact same process except moving up and down, where down is increasing value and up is decreasing value. Now we've got every step of the puzzle prepared. We have the player's position, the enemy's position, and the mouse's position. All we need to do now is move the enemy's position to the mouse's position relative to the player's position. Go ahead and click up here to table and show LUA Script. That's right, we're actually going to write code in the big 26 without Claude. The first thing we're going to need to do is define some variables. If you'll remember from before, we called our player's base address player. So we're going to define that like so. Then we're also going to define the offsets for the X coordinate and the Y coordinate of the player. Remember, 20 is the X coordinate and 24 is the Y coordinate. Now these offsets are in hexadecimal, so be sure to put the 0x in front of them just like this. Okay, now we're going to do the exact same thing but for the enemy. Remember, we called the enemy's base address enemy. And the X and Y coordinate offsets were the exact same as they were for the player. Next, we're going to define the mouse's coordinates. So go ahead and copy paste these addresses from the coordinates that we found. The next information we're going to need is the screen's width and height, which, believe it or not, are going to play a role in this script. Now the game probably exposes these values during runtime, so you could likely make a script that finds them just like we did with the enemy's base address and the player's base address. But usually you don't change your resolution, so for these values it's pretty okay if you just hard code them. So just replace it with whatever resolution you have your game set to in the settings. For me it's going to be 1920 by 1080. We're going to want to be able to toggle this script off and on, so we're also going to make a script enabled variable. I'm going to set it to true by default, so it's enabled right when you open the cheat table. Now this script is going to work on a timer. So the first thing we want to do is check if a timer already exists so we don't accidentally create a duplicate. The reason we need a timer is because we're essentially going to constantly run a function that moves the enemy position to the cursor's position. So just go ahead and write the exact code that I do. You don't need to understand how this works exactly, but just know that it's preventing duplicate timers. We're going to go ahead and do the same thing with our hotkey, which is the key that's going to enable and disable our script. Make sure your naming is consistent. You can use whatever names you'd like for any of these variables, just make sure you spell them the exact same way every single time. Now we're actually going to write the function that's going to run on our timer. We're going to call this moveEnemy. Now first, we're going to check if our script is actually enabled, because we don't want this function to run if it's not. So if not script enabled, we're just going to return and not do anything else. Now we're going to get our player's base address. That variable that we defined earlier was actually a pointer, so we need to read that pointer to get the address. Then we're going to do the exact same thing for the enemy. We're going to do some validation, so if either of these values are not defined, so if we forgot to get either of them from the scripts in our cheat table, we're just going to go ahead and return. Alright, now let's actually get our positional coordinates from those base addresses. We're going to do this using those offsets that we defined earlier. We use this method readFloat. That's going to go ahead and read the float that's at whatever address we input. And the address, of course, is going to be our player base address plus the offset. Now do the same thing for the player's Y coordinate. Alright, now we have the player's coordinates, let's get the mouse's coordinates as well. Again, you can do it this way, or you can do it using that getMousePosition method I showed you earlier. And I do recommend using the method instead, because it's more consistent. But either one will work. If you're going to do it this way, make sure you use readInteger instead of readFloat. Because remember, our mouse's coordinates were 4-byte values, which basically is an integer. Now again, we're going to do some validation, so if any of these coordinates are undefined, we're just going to go ahead and return. Now we're finally going to do some calculations using all these variables. Essentially, we want to get the cursor's position but in world coordinates instead of screen coordinates. We're going to do this by adding the player's position to the mouse's position and subtracting half of the screen's size. These are the coordinates that we want to set our enemy's position to. We're going to use the writeFloat method. This takes in the address that we want to write to and the value that we want to write. Our address is going to be the enemy's base address plus the positional offsets, and the values we're writing are going to be these coordinates that we just calculated. Next, we want to make a function that toggles our script off and on. This one's going to be pretty simple. We've already finished the bulk of this code. All we're going to do is set script enabled to not script enabled. In other words, if the script is running, we're going to deactivate it, and if the script is not running, we're going to activate it. Just like how a toggle should work. I'm also going to print enabled and disabled. This is just for the sake of debugging to make sure the toggle function is actually working properly. But you don't need to print anything if you don't want to, because it's ultimately not going to change the functionality of the code. Alright, finally, now we're going to actually create those timers and hotkeys that we were talking about earlier. We make the enemy move timer just like this, using the createTimer method. Then we're going to set the interval of this timer to 15. This is going to be in milliseconds, which means the function is going to run every 15 milliseconds. You can choose whatever interval you want, but I find that 15 works pretty well. Then we're going to set onTimer to moveEnemy. This is basically going to tell the timer to run the move enemy function. Next, we're going to create our hotkey like so with the create hotkey method. I'm going to make my script toggle off and on with F3, but you can use whatever key you'd like. Now at last, one final print statement to make sure the script is loading properly, and now all we have to do is press execute script. And there you go. Now you have a little slave vulture you can have your way with. Or if you prefer slimes, just hit that little bastard and he's yours. You can get a scorpion from the desert and sick them on zombies. And it doesn't even do bad damage. Somehow. As a matter of fact, the more I kept hitting zombies, the higher the damage got. And it started lagging my game out extremely bad for some reason. I don't know why this happened, but fuck it. Making discoveries is what makes cheat engines so fun anyways. Here's another discovery I made. It turns out it's actually really fun to play jump rope with the Eye of Cthulhu. I honestly didn't test this script much, but I'd be interested to know if it works with other bosses like the Wall of Flesh. So let me know in the comments if you do try it. Anyways, that's gonna be all for this video. If you had any issues with any step in this process, you can go ahead and join my Discord and I'm happy to help you out. Thank you so much for watching and peace out.